Inverse sine of negative 1/2. This means we want the angle, or angles, there's going to be two of them. We want the angles that have a sine of negative 1/2. So how do we do that? What's my first step? So fill in your quadrants, okay? A sexy tiger cat, or T-sac, some people like. All right? Yeah, so we first get what? What did I write on all the other ones? What three letters did I write? Ref, yeah. So first, what I'm going to do is I'm going to look at my two special right triangles, and I'm going to look at the angle. So there's no angle here that has a sine of negative 1/2, but there is an angle that has a sine of positive 1/2. Which angle is that? 30, right? If we look at 30 here, right, the opposite, here's 30, opposite is 1, hypotenuse is 2, opposite over hypotenuse is 2. So our reference angle is going to be 30 degrees, right? Okay? So what do I do with that 30 degrees? So I found the angle whose sine is positive 1/2. How do I use that reference angle to find the angles whose sines are negative 1/2? What do I do? What's that? Put it in the quadrant. Which quadrants are my answers going to be in, and why?
T and C.
Why T and C?
Because sine is negative.
Yeah, so in the T quadrant, right? T quadrant, that's the quadrant where only tan is positive. So sine's negative. This is the quadrant where only cosine is positive. So tangent's negative. Yep. So I'm going to have an answer in each of these. How do I find my answer in the T quadrant? What do I do? So I'm looking for an angle in the T quadrant. It's on the left side of my coordinate axes. I look at these numbers on the left end here. Okay? Let me erase this real quick. Okay? So I'm going to do what with that 180 degrees there? I'm going to do 180 plus 30 degrees. Why do I do plus 30 degrees and not minus 30 degrees? If I did minus 30 degrees, which quadrant would I end up in? S. Yep. So 210 degrees is one of my answers. Okay. How do I get my other answer that's in the fourth quadrant? I'm going to do 360 minus 30 degrees. Why did I do that? Why did I not do 360 plus 30 or 0 plus 30? Where would that have gotten me? I would have been in the A quadrant yet. Okay. And I need to do what with my final answer, so I shouldn't have circled this. What do I do with my answers? I want to put them in radians, so I multiply by pi over 180. All right, that's going to be what? 7 pi over 6. All right, and then what is that? 11 pi over 6? Those are my two answers, okay? Little review. Okay? Yes, no, maybe so. All right.
Why do you put the negative 1?
What's that?
Why do you put the negative 1? Like the exponent.
Oh, that's just notation for inverse sine. Yeah. It's kind of unfortunate. It's a little confusing, right? I think a better notation that we actually use in calculus, I think a better notation for this kind of problem, have you ever guys seen someone write arc sine? Have you ever seen? No, but it just means inverse sine. These are the same thing. But these can get confused, right? You can think that just means, this is not 1 over sine. That is not 1 over, that's inverse sine. But two very different things.
So what's the difference between like that and like just finding the sine?
Finding the sine?
Yeah, like what's the difference?
So if it were just sine of negative 1/2, that would mean negative 1/2 was our angle, and we were trying to find its sine. Okay? Since the negative 1's there, they give us a sine value, and we have to find the angle.
Oh, so that's just like the size.
Yeah.
Oh.
It's called inverse sine because it's backwards. It's inverted. Yeah. We can talk about inverse sometime in office hours. That's beyond the scope of this course. Yeah, a mathematical inverse depends on what operation you're using. All right. So let's keep going. Use a calc to round to the nearest 10,000, okay? What do they say? What does it say right after that? What do the directions say right after that? Use a calc, round to the nearest 10,000th. What is in those parentheses? Decimal degrees. Decimal degrees, okay? So what mode do I need to make sure my calculator's on? Degrees, okay? So make sure you're always on the right mode. Okay, my greatest fear at night. All right, keeps me awake at night is you guys using the wrong mode on a test. That keeps me awake at night. Okay? So mode. Oh no, I'm on radian mode. Let's make sure I change to degrees. Okay. All right. I want to find the inverse tangent of negative 1.43. So, okay. So the tangent button's right here. If I do second and then hit it, it'll bring up inverse tangent. Then negative 1.43. Give me negative 55.0349. Degrees. Okay? Anyone having trouble using their calculator to do that? All right. All right. Inverse sine of 0.761. All right. So again, there's an inverse sine symbol right here. Sine to the negative 1. Okay. So hit second. Sine to the negative 1. What's my number again they want? 0.761. Okay, hit enter. 49.5524. Again, make sure you're putting your little degree symbol there because this is in degrees. All right, secant. Inverse secant of 1.98. We want the angle whose secant is 1.98. Okay? What do you guys think we do? No, not 1 over inverse cosine.
Just 1 over cosine.
So if I have an angle, right? And that angle secant, the secant of that angle is 1.98. What's the cosine of that angle? It'd be 1 over 1.98, right? Okay. So what I need to do with my calculator, I'm not flipping the whole thing. I'm not flipping the entire expression around. I'm only flipping what's inside the parentheses. So I'm going to, the angle whose secant is 1.98 is the same angle as the angle whose cosine is 1 over 1.98. Okay? So that's how I have to, right? There's no secant, there's no inverse secant button on my calculator. I have to use the inverse cosine, so I have to flip it. Flip just the guy inside the parentheses. Okay? And I think you guys know how to do that. Inverse cosine. So second. Inverse cosine 1 divided by 1.98. Okay? 59.6653. There you go. Okay. All right, this next 4 are pretty tricky, okay? So let's please pay close attention. Maybe even don't take notes for this first one just so you can watch me do it, okay? These next ones are pretty tricky. Okay? We want to find the sine of the angle. Wait, do we get a calculator? If we get a calculator, it makes it actually pretty simple. Yeah, we do. Let me see what I did. If we get a calculator for these, it's actually not too bad. If we don't get a calculator, it's pretty challenging.
Will we ever not get a calculator?
Let's see. Well, on the quiz, you don't get a calculator. So yeah. Short answer is yes. she did. Okay, she did do it by hand. Okay, so this is tough, okay? We don't get a calculator.
Gross.
How do I get it on like cosine negative? Like up there, like cosine.
How do you cosine negative 1 then? Yeah, it's not going to accept 8. It's only going to accept numbers between -1 and 1. Notice, yeah, you have to put in, so that's why we have to put in -1. Yeah. There's no such thing as, there's no angle in the world that has a cosine of 8. That's why it's not. All right, here we go. Here we go.
So if it was asking for like cosine of something on the test, if you put like cosine of 1 over blank, would that be wrong?
On the test, yeah. Yeah, it's a little different because what we're doing on the test,
So I just lost
we only for like inverse, yeah.
There was like 3 point questions that I like put in my calculator and I just got that. It's like
All right, sine and inverse tangent of 0.1. So here's what we're gonna do. Focus on the stuff inside the parentheses. Work your way inside out. Okay. I'm gonna label this is an angle in here. This is an angle. I'm gonna call it theta. Call it theta. Okay? We want the sine of the angle whose tangent is 0.1. Okay? What do you guys think I'm going to do? We can draw, so if we have an angle, we know what its tangent is, we can draw what? Right triangle. Right triangle, okay? Okay, I'm going to put theta on one of my angles here. I'm just going to pick one. I like to do it on the bottom, just for consistency. You could do it in the top. You just have to switch some things around, okay? What can I put in here? If theta's tangent is 0.1, what 2 sides do I know about? What's tangent equal to? O over A, right? So what should its opposite? What should the opposite leg? What should its length be?
1,
Yep. What should the adjacent be?
10.
10. Yep. All right. So if we take the tangent of theta, we get 1 over 10 or 0.1. Okay. Well, how can I fill in that third side there?
Wait, how'd you get that?
So I want, when I do opposite, when I divide this leg by this leg, it needs to be equal to 1 over 10. Point.
So it could be 2 or 20.
Yeah. So how do I fill in that hypotenuse? What do I do? Pythagorean theorem. So 10 squared plus square root of 10 squared plus 1 squared. So root 101. Root 101. Is that what we want to learn? Okay. And then what's the sine of this angle?
1 over
1/101.
There you go. Rationalize. You got it. Root 101 over 101. Say that 5 times fast. Oh, that looks terrible. That looks okay. That looks terrible. Sorry, I'll stop. All right. Okay. Can we do another one? All right, B. We want the secant of the angle whose sine is 2/3. The angle whose sine is 2/3. What can I do? All right, catching on yet? No? Okay. I can draw a right triangle.
Is that a 360?
I don't know. It doesn't need to be. It could be.
Like 2/3.
2/3.
So we're going to put theta here. No, I don't think this is 3690. Okay, so what 2 sides can I fill out knowing the sine? Opposite is what? 2. Wow. What's the hypotenuse? 3. Okay, how can I fill in that third side there? Pythagorean theorem. It's going to be what? Root 5? That bottom side there is root 5. Okay. Now I can just take the cosine, right? If if I'm looking at secant, if I want secant, that means I'm interested in cosine, right? What was our mnemonic device? If you're going to an SEC school, right?
Yeah.
And cosine on your loan. Right? There's no CSC schools. I'll make my own athletic conference someday. The Central Southern Conference. Okay, so what's my cosine? Cosine of theta is what? 5/3, so secant is what? 3/5. Okay. Multiply by √5 on top and bottom to rationalize. What, like the negative one there? No.
Just there.
If it were secant -1 or cosecant -1 or cotangent negative, we have to flip that to put it in our calculator. So yeah, going into this next one, right? So let's think about this. Okay, this one, a little bit of a curveball here, right? I have an angle theta, so this is my theta here. The cosecant of theta equals 3/2. What's the sine of theta equal to that? 2/3, okay? So we want to go ahead and rewrite this problem as tan of inverse sine of 2/3, okay? So as long as I rotate my top and bottom around, I can change that inverse cosecant to an inverse sine, okay? If you flip your angle, you can change it to an inverse sine. Alright? Now I can do what? Now hope it's becoming muscle memory at this point. All right, triangle, yeah? Use p-tag. Alright, he is your friend. Okay. Theta, what two sides can I fill in? Yeah, what's my hypotenuse?
3.
What's my opposite?
2.
2. Wow, okay. And then, how can I get that third side? √5. P-tag again. Okay. What's my tangent then?
2.
Yep, tan theta is 2/5, which is 2√5/5. And I rationalize. Okay. Doing all right?
Yeah.
Cosine of inverse sine of -1/5. Do that on your own. Tell me what you get.
Why is that one inverse?
What's that?
Why is that one like even double parentheses?
Because it's the negative. There's a negative inside there.
Does negative matter?
The negative does matter. The negative matters. What's that negative going to do to you?
Flip it.
Yeah. Well, it's not going to, sorry. The negative's not going to flip it. It's going to affect what quadrant you're in. So actually, I should leave this up. Sorry.
Do we have to name the quadrant?
What's that?
Do we have to name the quadrant?
Yeah. We need to figure that out. Are you guys a little stuck?
No, I just, with the other ones, did we name the quadrant?
We didn't have to worry about it because the angle was positive, so we just did. Yeah, I should mention that actually. Okay, here's what I'm going to do. I'm going to color in these two quadrants here. Okay. not sure how much mathematical detail I should give, but when you're taking an inverse trig angle, your answers are always going to be in one of these two quadrants. Okay? Your answers are always going to be in one of these two quadrants here, okay? When you do an inverse trig, okay? It's just, I can explain it to you at office hours, but just trying to get the right answer, know that your answer is going to be in one of those two quadrants. And since my inverse sine is -1/5, which quadrant is my answer going to be in? It's going to be in C, right? I want the cosine of the angle whose sine is -1/5. So your final answer is going to be positive, okay? So let's think about this. Okay? So we can do this, I think we can just ignore the 1/5 till the end. Okay? So let's just ignore the negative. Sorry, let's just ignore the negative till the end. So, okay, so let's look at this stuff, draw my right triangle. Okay. If the sine of my angle is 1/5, I can fill in the opposite and the hypotenuse. Would that be root 24 down here? Yeah. Okay. So here's my theta. What is the cosine of theta then? Root 24/5, right? Now at this point, right, the sine. So now we have to pay attention to that negative there. Now we do have to pay attention to it at the very end. Should my answer have a plus or a minus on it? Plus. Why should my answer have a plus on it? Yep. Yep, exactly.
Oh, just a roast Would you take off for not simplifying that fraction on top?
Yeah.
2/6?
Yeah, and then I would. So we got to simplify that square root up top, okay?
How do you know it's in the C quadrant?
So I know my answer is going to be in one of. Whenever I'm working with inverse tan, inverse cosine, inverse sine, right? When I evaluate that inverse sine function, I'm going to get my angle from one of these two quadrants. Which quadrant has angles? Which quadrant has angles with negative signs? A or C? Which quadrant has angles that have negative signs? C.
Okay.
Yeah.
So it's like 2 negative.
Yep. So 2√6/5, okay? Check your answers to number 3 with a calculator. Okay, yeah, now we check with the calculator. I'll do a couple of these. I'll just go till noon. So sine inverse tangent of 0.1. Yeah, this is the one thing I'm pretty sure you do get the right answer no matter what mode you're on. Okay, so sine inverse tangent of 0.1. So sine inverse tangent of 0.1. Okay. Switch to radian mode. Sine inverse tangent of 0.1. There you go. Okay. So you don't have to be as careful on those, what mode you're in, okay? What is root 101 over 101? Let's see if we got the right answer. So that's how you check your answer, okay? So plug in the problem to your calculator and then plug in the answer. Are we feeling okay? All right, 12:30. 12:30. 12:30. What?
I didn't think you could.
Yeah, wait.
What?
12:30.
12. That's not good.
I thought it was like, AC 130 there.
Any AC 130.
Yeah.
Ava almost got her.
I was gonna say I figured it's senior class.
Yeah, we gotta wait till everyone leaves class. Got somebody in here.
I'm gonna come in now. Thank you. I'll take it.
I'll do that during lunch.
No, like Libby
for
Lewis. You know
weather.
Libby Lewis.
Is she out here talking?
She could. I could handle yes.
She's an engineer, but so her little brother was Boy Scouts before I had.
Oh,
And
wait,
so,
wait, wait, wait.
yeah.
Okay.
No, the kid.
It's like 11 to 17s.
Yeah. So they have like a trip, like summer trip they were leaving for the day, but.
Well, I texted her. I was like, "Hey, do you remember her?" And she was like, "Yeah, that's me." And so she was like, "No." Yeah. So she was like, "Yeah, he's actually part of my brother's Boy Scouts and stuff."
The kid you had.
Yes, and so he was
But
like,
he wasn't going.
yeah, she was like, they're going on this big ski trip. They're leaving tomorrow at 5 a.m. Yeah. No, like to Colorado. They're leaving at like 5 a.m. and like, yeah, like at 5 a.m. But they don't get back till Monday.
Her brother was going really.
Yeah, well, we found that out later. We were like, well, you better get him money.
So then this whole plan.
No,
to, like,
I made up this
okay, yeah,
mastermind plan that I was like,
he
you
texted me and was like, my brother can't find his ski goggles, like in Europe. So we were gonna like show up to his house and like somehow get him to like bring the goggles outside so that I could get them out.
Oh, that's
And
epic.
so he left her Snapchat location.
no,
on.
I don't know why.
So,
I would no, it's because I'm not
she's
playing.
in town. She's kept it on, but she was with me the whole time, so he saw that she was like circling his neighborhood. And so
Yeah.
we get there and I like slide out the door, the car like crushed by the wheel, and they like
Oh,
pop in.
Libby calls him and was like, hey, we're here. And we're like,
She was like, sorry, I forgot to sit in the wrong
And
way.
he was like, hi, Kate. And I was like, what? And he was like,
as soon as we
yeah.
pull up, Kate goes from the front seat, crawls to the
No,
back
but he said he
seat.
didn't see.
So you were bringing ski goggles.
He
for
was,
the
we
little
were,
brother.
he was bringing
him
them.
up
Yeah.
for
And so
work.
then he goes,
But I was gonna get him out when he came outside.
then he goes, the ski goggles are in the mailbox. And
He's
we're like,
"Do not
ah.
slip, Kate. Snap
Yeah.
Kate has it, which is good.
Wait, are you finding it? You said you
No, but he thinks I have it. He's like freaking out.
Wait, did it not announce when you get out? They don't?
No, I didn't get out. I didn't get out. I just hit it by back because I didn't get my purse in.
Oh.
Yeah.
She like could have bought back in, but no.
Yeah. So now he thinks I have, but it was dumb actually.
I never thought about Boy Scout. Our Boy Scout trip like off limits?
Yeah, I don't know.
Go to Colorado.
Well, you gotta tell
You
us.
could.
This morning I tried to
You gotta figure that out.
And his house is like, his driveway is so long. Like if this is his house, his driveway is like this long like path, and it's like lit up. So I'm like, okay, how am I gonna get back there? And so this morning I got there at like 7:15, and his garage isn't connected to his house, so he's like on the side of the car. So I'm like hiding behind this garage building. I'm wearing like all black.
It's
and
like another
like,
tent again.
yeah, this morning, and it's like this bright white building. So I'm like just standing behind like garage, like okay. And then I'm like hiding behind these trash cans, and I can like see his like side door that he would like come out to go to his car. And then this dog starts coming out. It's like barking at
She's
me. Like,
texting me. She's like, this dog is going and she's barking so loud.
So
You're
I'm
like
freaking
right
out.
beside
I'm
the
ran
house.
behind, so I'm like just standing behind it now, so I have no view of like where he is. So I was just like.
This is in the morning wave.
Yeah, I was like waiting for him to leave. It's like 7:50, and then all of a sudden I just see lights shining through the garage window, and he's backing out, and I was like, oh.
Did he see you there?
No, he
Obviously.
still doesn't know that I have him, which is
Yeah.
good, but I'm leaving school early, trying to get
You're leaving school early.
To go
Just so
hide
I can
behind
get
the
out
thing.
and get there before he gets there.
Because he used to get out of his car to get to
That's
his
the
house.
only
Like,
time
the
we
garage
go.
thing
Oh, you're
connected
at
to
his
the
house.
house.
Yeah, like
It's
the
not.
garage, no, it's like
How do you
garage
get
and
in?
then house.
Oh, because
Yeah, because
That's why I was gonna investigate. There's like a
Because
side
he was
door that I
tweaking
could,
about
like-
the dog barking at her.
Okay.
Because I was, I don't
Yeah.
know, is it pretty obvious?
What does he do? Is it just like the garage?
He's
No, he
really
likes-
serious about
no,
this.
he
Is
was
there a
really-
bathroom in
really-
the garage? Or?
I think he was like lurking in a window last night when we showed up because he was like sleeping, and we were like, you were like, oh, what? At least he didn't see me, but like,
Yeah, he's
it was
he's
really
really
funny.
really
We thought we had like a good plan last
He even
night.
said he texted me and was like, "That was such a good plan. Your snap maps gave it away." I don't know why he would tell me that though.
Yeah, but I was like, eight.
So I just turned him on. But I'm not playing right now, so I just turned
You
him
are
back on
there.
with my friend.
Well, then I told her to keep him on this morning because he was tracking her, and then she was just acting, and she fell over the bed. Well, the dog, I thought it was a big dog. It was like this big, and when I saw it,
I said she should bring treats next time. We started
Yeah. It's like what like home invaders.
She told my mom
Yeah,
my mom's
like
like, but then the
retreats.
dog's just gonna stand there like looking at the bush if you're like hiding. Like, and so then the kid would be like, where's the dog going? That I would get him out.
You just see trees getting thrown across your line.
The dog's like,
That's epic. That's hilarious. I love these.
Yeah. So, if we have any other ideas?
Yeah, for sure. That's hilarious. I never thought about like a skip. So, like, you gotta figure out. You know what troop is in? You gotta get on. You know what you gotta do?
The reason is on right now. They're all like ski.
Alright, you know, be super happy. I'm doing chaperoning tickets. Like,
Last
on
year,
tickets.
I had to be in like flight suits and stuff, fly sims for people and like fly drones for people.
What?
Clean sheet.
Well, it was Chapaco, maybe because like I'm
Stick around the wax.
Well, 'cause
I had run sims and like like for people flying. Don't fall on it. Don't break it.
Yeah.
They thought, I mean, I think you drink so much alcohol.
It's so weird how like Shamrockshire is like the one night a year, and like they just like no boundaries. Like we'll just
No,
let people
it's-
be really drunk around
They
kids.
literally just.
It's just like,
wasted.
and like when I was a student, I was like, this is hilarious. But now it's just like, oh.
No, like, and I mean, I get it. A few drinks, you know, makes people spend a little bit more money. I get it,
Yeah.
but
Some of the teachers used to get like
Really?
drunk. Yeah, when I was a student, it was kind of weird.
there are.
What?
Mr. Miller got crazy.
Mr. Miller was not going crazy.
I know that there were a few admin last year.
That got
who-
drunk?
I wouldn't say they got drunk. They just lost. Like they lacked composure of like a typical person that would work.
Oh, okay, yeah. They were having a good time. They were having a good time. That's fine.
Like they weren't stressed out type.
Yeah.
Like happy drunk, yeah. Like
That's
they,
good.
They could drink it, but like they just.
To the point of hilarity. Drink to the point
Like
of
they're
hilarity.
not at a work function. They're at a gala.
My mom's doing student volunteer check-in. So you can
Really?
meet her.
That's me. That's yeah.
All right. On the bottom of a 20-foot. Wait, let me see. Did she do? No, she didn't even do these. We're on 5. Okay, we're skipping 5, so now we're on 6. All right. We're skipping 6, so now we're on 4.8. So we're done with 4.7. And it's all 3. The homework's too much to ask. Is it too much to ask for Tuesday? I guess have 4 days.
But we have seen
I have like a lot to do.
I have a lot to do too.
So then you won't have to read them all.
There you go. Okay, 4, 5, and 4, 6 for Tuesday. Someone said I'm next senior 6. Senior 6. Alright. What?
Mr. Rushka, I hate this.
Alright.
Mr. Shabby.
Didn't we already talk about this basically? Yeah.
Wait, are we skipping all these work problems?
No, we're not skipping this one. Find the angle of elevation of a bird is in the top of a tree from a point on the ground 100 feet from the base of the tree. The bird is 18 feet underground. What do you think we're going to do? A good word problem that involves angles and stuff. We're going to draw a picture. What do you think we're going to draw?
A bird.
Right triangle. Love it. Love it.
I'd actually rather build a tree just so that my mind can be quick.
That's for you? No, do that later. We're doing that. Okay. Right?
Is that the biggest bird?
All right. So what are my lengths? What are my leg lengths? What are my leg lengths? 18 feet above the ground. So where do I put 18? On the tree. And the tree is 18 feet tall. We're 100 feet from the base of the tree. And we want what angle? Which angle here is my angle of elevation? It's always on the bottom. Even for depression as well. We gotta find that angle. What are you gonna do? What are you gonna do? Not gonna do Pythagorean theorem. We gotta find the angle. We gotta find theta. How can we find theta? Which one am I gonna do? Why don't we use tangent? Yeah, so I have, right, we have theta, we have the opposite side and the adjacent side. Which trig function involves those two? Tan. So we want the angle whose tangent, right? The tangent of theta equals 18 over 100. So So we want the angle whose tangent is 18 over 100. Do you guys want me to keep like filming my calculator? Or do we know at this point?
You know what it is.
Gonna whip through this. 10. I got 10 point. Round the nearest hundredth. I got 10.20 degrees. Wait, am I in the right mode? It doesn't say what they want. It just says round the nearest hundredth. Let's do degrees. Okay, I got 10.20 degrees. So you guys got it or no? No?
Yes, that's what I got.
Thank you. Not a rhetorical question. What?
I don't own a calculator.
Don't know calculator.
I got 2. Can you one?
Yeah. Copies.
Just graphic.
Hey, all right, number 2 or B. Find the distance from a worm on the ground to a bird on the top of the tree. If the bird's angle of depression to the worm is 24 degrees and the tree is 19 feet tall, what am I going to do?
Draw a tree.
Draw a right triangle. Draw a tree, draw a right triangle. Okay. Tree is 19 feet tall. Where do I draw 19? What do I label with 19? Tree, the vertical side. Angle depression, right? I muffed this the one day. Which angle is my angle of depression? It's always the bottom. We want what? We want the distance from a worm on the ground to a bird on the top of the tree. So which side am I trying to find? The other leg or the hypotenuse? Hypotenuse, yeah. The hypotenuse. What am I going to do? How do I find that? Sin.
And then like 34.
Sin of 24 degrees. What's that going to equal? 19 over x. Nope, because sine is opposite over hypotenuse, right? Opposite over hypotenuse. So I got hypotenuse, but I don't know these two. Right?
Wait, what?
Opposite over
sorry.
hypotenuse.
I got it.
So you guys know how to solve this for x or no?
Don't you like multiply by
So
x?
multiply by x on both sides. We get x sine 20 times sine of 24 degrees equals 19. Divide both sides by sine of 24 degrees. X equals 19 divided by sine 24 degrees. Make sure you're in degree mode. I haven't used degrees since high school.
Fancy calculator.
Always radians in college.
Yeah, you just.
You need to get used to it, just like you get used to all the proofs. Yeah, we'll grind you out, man. We'll grind you out. I'm not worried about you.
You should have done
You're just an idiot.
All you do. There's still even time to.
Yeah, you can learn from mine. You gotta
Learn
throw a
from-
lip on the test.
Oh yeah.
That'd be.
You recovered though. All right, how tall is we should that one there. How tall is the flagpole that casts a 23-foot shadow? What do you think we're gonna do?
Draw a flag.
Draw a right triangle. Draw a flag.
What's flag?
What do you guys want me to draw? Gosh.
Japan, Croatia.
Japan? Okay. Japanese flag.
Just do a red circle.
It's waving in the wind.
Did you just ask that?
That's actually pretty good. Yeah, interesting. Sweden was it. Missed opportunities to still function.
All right, there you go. There's your flag.
This.
Right? 23-foot shadow. Where do I put the 23?
The bottom.
Bottom. Angle of elevation. The angle of elevation of the sun. It's just always on the bottom. Yeah. I don't know what. I actually don't know what angle of elevation of the sun is.
Why would it not be at the top?
It's always at the bottom.
Just wouldn't the sun be casting it this way?
No, I think so. What's going on here is angles of elevation are always measured from the ground. So here's the ground, right? The angle that the hypotenuse makes with the ground is 32 degrees. Okay. Angle of depression is always in the bottom because angle of depression is measured from the sky. And so the angle of depression is the angle that the hypotenuse makes with the sky. And then we can transfer that down to the lower left corner with alternate interior angles from geometry.
I hated that.
Yeah. Tutoring my geometry students tonight. Hey, buddy. What kind of angles are these? Okay. I love it. Great kid. Okay, so then what do we want? What do we want to know? What are they asking?
How tall's the flag?
How tall is the flagpole? Okay, so I'm going to label the height of the flagpole with X. Oh, what can we do to find X? We have which two sides are in play here? Which two sides are in play?
Hypotenuse and
We don't know the hypotenuse, so we're not trying to find it either. Yeah. So what do you think we're going to use? What? Opposite and adjacent. SOHCAHTOA. Tangent. Yep. So the tangent of 32 degrees equals what? Yes. So multiply both sides by 23. X equals 23 times the tangent of 32 degrees. I got 14.37. What you guys got? Stop. Nice.
let's see, drop
Bless you.
Thank you.
Bless you.
All right, this one's. I feel like it's a pretty similar problem. I don't know why I took it different number. What do you think I'm gonna do for this one? What do I do for number 2? If Kirsten has got her surveyor's telescope, it's actually called. I thought it was called transit. Anyone ever use a surveyor's telescope?
I
Oh,
did.
I have. I actually have.
I used to have one.
No, what is that?
I think it's just a transit. Yeah. I used one of those before. We called it a transit.
I think the official name for that specifically.
You feel like so legit when you're using one. You're like, yeah, I use one of these. So fun. It actually was not fun. Surveyor. So you're using one of these. Okay. You're doing surveying. What's that? Just a watch. It's like I used it to get like perfectly level. I was building a retaining wall and I had to get like the bottom of it perfectly level. So I had to like.
Why were you doing that?
Long story.
In
What?
college?
No, this is high school.
Just like for fun.
No, not for fun.
Here?
No.
I'm sure you
Did you go here?
Yeah.
Yeah. That was
Is
a
that?
question on the
I got that on the test.
It really was?
I put
Wait,
you,
you were
3G, and Miss Y.
In Eagle Scouts?
I was, yeah.
Wow.
That's so
Thank you. Okay. Thank you guys. Thank you. Okay. So what do you think I'm going to do for this problem?
Well, you gotta draw your transit.
Okay, let's draw a transit.
You know best.
Okay, so So, how tall is the transit?
What's that cap?
5 feet.
5 feet. Yeah. What do you think I'm gonna do? Yeah. Draw a right triangle. Thank you. Draw a right triangle. This is a little different, actually. So here's what's going on, okay. What's going on here, so we're still going to have a right triangle. Sorry. This is scratching. Just blame it. I never take responsibility. So we're going to have a right triangle. Here's what's going on. So they're trying to figure out the height of the tree. Okay? So here's the tree, X. I'll actually draw a little tree here. But what's going on is they're making all the observations of the height of the tree from a surveyor's telescope. So I'm going to draw a little pink dot. The surveyor's telescope is right there. Everything that they're measuring is already 5 feet above the ground. So we've got to draw like everything on a 5-foot platform. And then the tree's 120 feet away. And it's an 8-degree angle of elevation. Okay. So the height of the tree is not just going to be X, it's going to be what?
X plus 5.
Height's going to be X plus 5.
Isn't it measuring to the top of the tree? So would that be that high?
She measures an 8-degree elevation above the horizontal to the top of the tree. No, the tree's 120 feet away, not the top. It's to the top of a tree that is 120 feet away.
By the top of the tree.
Yeah. So it's going in just an extra 5 feet because you're taking the measurement 5 feet off the ground. Sorry about that. So what's going to happen here? So we can solve for x, add 5. That's our answer. Okay, we good? Okay. How do we solve for x? We have our opposite side and our adjacent side. Tan 8 degrees equals x over 120. 120 tan 8 degrees equals x. X equals 16.86. Do a little bit of a plus 5 action. Just add plus 5. The answer is 21.87. Add 5 to your x. Okay. What's that? There you go. Number 3. Any ideas for number 3? Very good idea. However, Miss White skipped it in her notes. So we're just gonna skip it. Gotcha. Gotcha.
He
Alright.
really needed it.
Yeah, he really needed that today.
Sorry. I said it was a very good idea. It was a bad idea. We're just not doing that wrong. Alright. I love this one. Large helium-filled penguin. I haven't talked about penguins in a math or physics class since I took particle physics. But, because the professor was the greatest professor ever. David Egolf. Oh, the dude literally made these problem sets that were so hard it was impossible to do them without the professor. But he stayed after class for 4 hours after every class, and so we just hung out. And then he'd take us out for beer and pizza, like literally every class. We just like, yeah, we were 21. Yeah, we were all 21. Yeah, he would take us out to like this super nice pizza place like every Tuesday, Thursday after we did our homework.
Wait, I thought you said that.
Did you do that with the other teacher? Yeah.
No, that was the guy.
You would like go to his actual dorm?
Oh no, that's another. Oh, that's another
That's
guy.
the dude I was gonna say. I thought you made like.
Yeah, I never had him as my professor. He had like a social event every Thursday night at 10. This priest who lived in my freshman dorm.
So you would go and get pizza and beer with the professor and then go in.
Yeah, and then I'd go and like have brownies and quesadillas. Yeah, it was so college was the best. You guys would love it. You guys would love it.
Wait, you went where?
All right, got a large helium-filled penguin. Some more of the beginning of parade routes. All right, so we got our penguin. Okay, let's draw a penguin. there's two cables jutting out of this panel. Okay? There's two cables, so I'm just going to draw it from this point right here. There's two cables jutting out, so here's the ground. Let me draw the ground. And there's two cables coming out of the penguin. And then they're gonna want, I'm gonna draw this in dotted lines. Okay. We've got a right triangle. Wouldn't be calculus class of a right triangle. Okay. So what's going on? One of the cables, so the two solid black lines, one makes an angle of 40 degrees with the ground, the other one makes an angle of 48 degrees. Okay, they want to know what? What's a good question? They want to know? They want to know how high above the ground is the bank, so where do I put my X?
Where a dotted line.
Yeah, dotted line, that's going to be my X. Okay. Okay. And then we can fill in, we need some more information, right? So the cables are attached to the ground 10 feet from each other, so that's 10 right there, okay? Yeah. I think that's about it. Cool. Yeah, I got nothing else. Alright, so we don't know this distance right here. The distance between the closer cable, between this cable and then like the point right below the penguin. Okay. We want to find X. Any ideas? Any ideas? We want to find X. It'd be nice if we did D, right? If we did D, kind of problem would just come out right D. Yeah, just answer be not too bad to come by. Right? We don't know D. So what do you think we can do? What's that? We can't. So we can't run a hypotenuse because we don't know D, right? I wouldn't recommend that. That'd get really sticky. Yeah.
We can find X of the, we can find the height by using, can we just use 90 and 48? Or like we do tangent 90. No.
So there's two angles in this problem, yeah.
Do we find the hypotenuse of the really like bigger triangle?
I don't think so, not quite. So there's two angles in this problem, right? They gave you two angles. What do you think you're going to end up doing?
Just find all the other ones.
You're going to end up using one of the trig functions twice, okay? So one of them, okay, tangent of 40 degrees is going to give me what? What's tangent of 40 degrees going to be? What's the opposite? What side is opposite 40 degrees? X, okay? We might have trouble seeing that. So I actually have two right triangles here. I have a big one, and then I have a smaller one that's nested inside the big one. I think students have trouble seeing that. So looking at this big right triangle, I can take the tangent of 40 degrees, and that'll give me X over what? What's the bottom here? What's the adjacent side? 10 plus D, okay? So tangent of 40 degrees is going to be X over 10 plus D. Okay? What's tangent of 48 degrees going to give me? X over D. Okay? So we've got two equations and two unknowns. Okay, right here. We can go ahead. You good?
Yeah.
Okay, cool. We can go ahead and solve for X. Okay? So, what I'm going to do, what's my strategy be? Yeah, I'm going to do that. So, yeah, I'm going to solve the bottom one. I'm going to solve the bottom equation right here. I'm going to solve that for D real quick, and then sub it in for D right here. Okay. So, solve this for D, sub it in for D right there, okay? Sorry, you're wet. Nice. Is that what I tried to do? So X is going to be equal to D times tangent of 4. Oh, wait, I just got x by itself. D times tangent of 48 degrees, that's fine. Alright. So this will be useful later. This will be useful at the end of the problem, okay? So let's sub that in. Let's sub that in up here then for x. Okay? We get tangent of 40 degrees equals d tan 48 degrees over 10 plus d. Okay? Now we've got one equation and one unknown. I can solve what's on the screen there for d, okay? So I'm going to multiply both sides by 10 plus d. I don't want any d. I don't want the letter d in the denominator. So I have 10 plus d times tangent of 40 degrees equals d tan 48 degrees. Okay, I'm going to distribute this tan 40. So when you guys see tan 40 degrees and tan 48 degrees, think of them. I know it's confusing because there's letters. Just think of this as one number. Think of tan 48 degrees as one number. Think of tan 40 degrees as one number. Okay, so I'm going to have 10 tan 40 plus d tan 40 equals d tan 48 degrees. Okay, don't get lost. Don't get lost. What are we trying to get by itself here? Which part of this equation do we want by itself? D. We want to get d by itself, okay? So how do I do that then at this point? So we get all the d terms on one side and all the terms without d on another. So I'm going to subtract this d tan 40 degrees over to the right side. Okay? What am I going to do at this point? I'm trying to get d by itself. There's two d terms. I don't like that. How can I make this? How can I make it so there's only one d? I'm going to factor out the d. Yeah. All right, and then I just have to divide both sides by tan 48 minus tan 40. So I get 10 tan 40 degrees all over tan 48 degrees minus tan 40 degrees equals d. So that's going to be really useful. What can I do with that expression for d? What's x equal to? X is equal to d times tangent of 48 degrees, right? So if I take this guy, if I multiply both sides by tan 48 degrees, that's going to be equal to x, okay? All right. Yeah, so I've got to put in my calculator. And I'll show you guys how I did it. So here's how I put that in my calculator. I put the top in, okay, I hit enter, and then I hit answer divided by, and I put the bottom in parentheses. Okay, so I got 34.3, yeah, 34.3 feet. Quick story. So the last time I saw penguins was in particle physics class. Okay? The person, so there are these diagrams in particle physics called penguin diagrams. The person who came up with them lost a bet and had to use the word penguin in the next physics paper that they published. So they're now called the penguin diagrams.
Oh my god.
So like this person was like publishing a physics paper, and they lost a bed, like while they were like out on like some boys' night or something. And so they had to put penguin in the next paper somehow. So the person like used this type of diagram invention in the paper.
And it got really toxic.
And he called them penguins. Because the diagram comes
Yeah, we
Does it have anything to do with penguins at all?
No, but the diagram looks like penguins. They actually do look like penguins.
Add letters, animals. Yeah.
Are you guys taking care of your work today? Yeah.
That
Great, man.
Can't expect us to do that last one on the test, right?
Well, not no practice.
I have an alpha, yeah.
That was tragic.
You were.
The last one.
Watching it unfold.
Yours probably Tuesday also.
You guys are gonna. It's so hard. I can't. You don't even know.
No, I kind of understand it now. After we like came and talked.